Hi, welcome to another lecture in the series of engineering chemistry that we started. We've had three lectures, so I would recommend that you go back to those three lectures and refresh your memory. And this is lecture four. So for lecture four, we're starting with chemical equations. So we want to see how to write chemical equations, how to balance them, and how to balance some difficult chemical equations that we might encounter. So, for any given chemical reaction, mass is always conserved. That means that the total mass of the reactant must be equal to total mass of the product. So, when you react elements A and B together to form the product. The mass on both sides must be equal, otherwise, we will say mass is not conserved. So, to ensure mass is conserved, the number of atoms for each element in the reactant and the number of atoms of each element in the product must be equal. So, when we check the number of atoms on both sides, and they are equal, that is when we can now say the mass has been conserved. So this is a typical example of chemical equations where you have element A reacting with element B to form a compound. Remember, one of the properties of a compound is that a new substance is formed. So it's going to give you AB, and this AB is going to have its own characteristics as it's different from the constituent elements. So writing a chemical equation, this is an example. We have hydrogen reacting with oxygen to produce water. So hydrogen and oxygen, they are the reactants and water is the product. So on the left side, you have your reactant. On the right side, you have the product. Now let's check. Mass has not been conserved for this chemical equation because the equation is not balanced. As you can see, you're having two hydrogen and you're also having two hydrogen balanced, but we're having two oxygen and having one oxygen on the right side. So it's not balanced. So we have to take a step further to balance the chemical equation. And how do we do that? So we check one by one. We check for hydrogen first. You can see we have two hydrogen and we have two hydrogen. That means hydrogen is balanced, but oxygen is not balanced. What can we do to balance it? So we're having two oxygen on the left side. So to have two oxygen on the right side, we have to multiply it by two. So when you multiply by two, you're going to have two oxygen, two oxygen. So oxygen is not balanced. However, we have created another problem because the number of hydrogen is not balanced. So as you can see, we're having two hydrogens here, but we're having four hydrogens. That means we have to do something to the left to make it equal to the right. And what do? We multiply the left by two to give us four hydrogen. So at the end, we now have four hydrogen. We're having two oxygen, and we're also having two oxygen. Now the equation is balanced. This is a very simple type of chemical equations that you can encounter. So another thing that you can do on a chemical equation is to add the states. So as you can see, hydrogen here, there's a G there. That G means it's in a gaseous state. Oxygen also it's in a gaseous state, and even the product it's also in a gaseous state. So we're having three states. You can add the state of reactant and product. So for G means gas, L means liquid, and S means solid. So when you have AQ, that's aqueous. That means you have a solute inside the water, and water will be the solvent. Another example is the combustion reaction when you have methane burning in the air to produce CO2 and water. So from the chemical equation, you can see we're having one carbon on the left, one carbon on the right. So carbon is balanced. But we're having four hydrogen on the left, and we're having two hydrogen on the right. So hydrogen is not balanced. The same thing, oxygen, two oxygen here. but we're having 3 oxygen on the right side. So we need to balance it. Now, when you see, you might want to ask yourself that, where do I start from? What element should I balance first? Now, this is a clue that you can use. So those elements that occur in fewest chemical formulas on each side of the equation. So for example, for this equation, we're going to start with carbon, because carbon is the fewest. It occurs as the fewest in the chemical formula. You can see only one carbon and only one carbon. So it's the fewest. If you compare it to oxygen and hydrogen, is the fewest element in the reaction. So you can start by balancing carbon first. So now, if you try to balance carbon, you can see that carbon is even balanced already. You don't need to do anything for now to carbon. Let's see. So from there, we can now say, okay, let's balance hydrogen. So we're having 4 hydrogen on the left, 2 hydrogen on the right. What do? That means that we're going to multiply 2. We're going to put 2 in front of water so that hydrogen can be balanced. Now we have 4 hydrogen on the left, and also we have 4 hydrogens on the right side. So hydrogen is not balanced, carbon is balanced, hydrogen is balanced. Now let's look at oxygen. Now we need to check from this equation, we're having 2 oxygen here, and we're having 4 oxygen on the right side. So this is 2, and this is 2 times 1, which is 2. So that means we need to add 2 more here. And what can we do? It's just multiplying it by 2. Then you're going to have 4 oxygen. Then we also have 4 oxygen. So now it's balanced. Then you can now take a step further by adding the states of the reactants and the products. So for the reactants, they are all gases. The products are also in a gaseous state. Again, there are some chemical equations that it might be difficult for us to just balance by inspection. Some chemical equation from the previous one that we've done, we can just look at them and balance them by inspection. But in some cases, for example, the case that we're having here, you can see that it has a lot of elements in the chemical reaction. So it might be difficult for us to be looking and be balancing. This is a typical example of silver sulfide reacting with potassium cyanide in the presence of oxygen and water to produce this product. So to balance them, we use something we call algebraic expression. And how do we do that? This is what we do. We put the coefficients A, B, C, D, and so on and so forth at the back of each compound or elements that are involved in the reaction, and even the product as well. So we can just start by saying A, B, C, D, then E, then F, then G. So we don't know what those coefficients are, so we just put them there. Then later we solve for them. Fourth, let's look at how many elements do we have in this chemical equation. We can see we have silver, we have sulfur, we have potassium, we have carbon, we have nitrogen, we have oxygen, and we have hydrogen. So it's a lot. You can see that it's a lot to balance. So that's why for this kind of reaction, we say, okay, let's use algebraic expression. So for the reactant, how many silver do we have? You can see we're having 2 times A. So that means that we're having 2A. On the product side, how many silver do we have? We only have 1 silver. That's 1 times E. That will give us E. So for silver, it's 2A equals E. Let's move further. So from there, we have sulfur. How many sulfur do we have here? We have A. That's sulfur 1 times A. That's A. And how many sulfur do we have on the product? We have just F. So A equals F. Then we move further. How many potassium do we have on the left side? We only have B potassium. That's B. How many potassium do we have? We have E potassium, and we also have G, potassium. So we have to add them together. That's E plus G. Then we move to carbon. How many carbon do we have on the reactant side? We are having one carbon, which is B. How many carbon do we have? This is 2. So you have to multiply this 2 by carbon. That is 2 carbon multiplied by E. That makes 2E. So for carbon, we have B equals 2E. So for nitrogen also, how many nitrogen? We are having B, nitrogen. How many nitrogen do we have here? This is 2 times nitrogen, 2 nitrogen times E, that's 2E. So that means B equals 2E. For oxygen, how many oxygen do we have here? We have 2 times C. And then we also have oxygen here, which is 1 times D. So that means we have 2C plus D equals, how many oxygen do we have here? We only have oxygen here, that's G. So that's why we have 2C plus D equals G. How many hydrogen do we have? We're having 2 times D. That's 2D. How many hydrogen do we have here? We're having just G hydrogen. Now that we have this, now let's move further. And what do we do? There's an assumption that we're going to make here. We say, okay, let A equals to 1. Let A equals to 1. So when you're solving this kind of a thing, you have to assume one of these. And I will encourage that you always assume 1 and you assign that 1 to A. So let's say A equals 1. That means for this expression, E is going to be 2. How? Because A is 1. So 2 times 1 equals E. That means E is 2. So now we know E. Let's go to sulfur. We already know that A is 1. That is 1 equals F. That means F equals 1. Let's go to potassium. B equals E plus G. We only know E and we don't know G. So we can leave it like that for now as B equals to G. Now, let's go to carbon. B equals to E. Now we can get B from carbon. So what is going to be B? B is going to be 2 times 2 because E is 2. So now from there, we can know that B is 4. So if you go to nitrogen, we can also see nitrogen is B equals to E. B will also be 4. So we can now go back and solve for G. As you can see, though we have G here, but now that we already have an equation that involves G, and you know that B is 4. So B is going to be 4 equals 2 plus G. Then G is going to be 2 from this equation. B equals 2G, and we know that B is 4. So it's going to be 4 equals 2G, and G will be 2. Now that we know that, let's go to oxygen. 2C plus D equals G. We already know that G equals 2. Okay, so if you know that G equals 2, how can we solve for C and D? We don't know C and we don't know D. So we know that it's going to be 2 equals, because G is 2. So it's going to be 2 equals 2C plus 1. Oh, where do we get this 1? Now let's go down. For hydrogen, we can see it's 2D equals G. And that we know G to be 2. That means 2 equals 2D. And from here, you can see that your D is going to be 1. So from there, we can now slot that D into this equation. So we now have 2 equals 2C plus 1. So C is going to be 0.5. Now we're done with that. Let's move forward. Now, we have, at the end of the day, we're going to have our A equals 1, B equals 4, C equals 0.5, D equals 1, E equals 2, F equals 1, and G equals 2. But look at this. If you remember from our previous lecture, we said that compounds, they don't combine together in fraction. So we cannot have fraction. So how are we gonna avoid this fraction? He said you should divide the coefficient, all the coefficients, by 0.5. So by the time you divide by 0.5, this fraction is going to be 1. Okay, so we're going to eliminate the fraction. 1 divided by 0.5 is going to give you 2. 4 divided by 0.5 is going to give you 8. 0.5 divided by 0.5, it gives you 1. 1 divided by 0.5 gives you 2. 2 divided by 0.5 gives you 4. 1 divided by 0.5, it gives you 2. 2 divided by 0.5 gives you 4. Now you have your all the coefficients, and none of them is in front of in form of fraction. So now you can now begin to slot in. Your A is 2, you can put 2. Your B is 8, you can put 8. Your C is 1, you don't need to put it, it's fine. Your D is gonna be 2, so you can put 2, and so on and so forth. Your E is 4, your F is 2, and the last one, that's G, is 4. Now this equation is balanced. So you can see that if you use this method, it's going to make it easier for you instead of trying to guess, okay, what number should I add, or what number should I add first, or which element should I balance first. So learning check. So you use the what we've discussed earlier to balance these equations. Let me tell you this: it doesn't matter the method you use. If you can do it by inspection, then it's fine. All we are interested in a balanced equation. So if you decided to use algebraic equation, it's fine. And also, if you can do it by just looking at it and assign the number, or like I said, all we're interested in is for you to have a balanced equation. So try all these exercises. So then we move to types of reactions. So we're gonna discuss basically 5 types of reaction. Reaction 1 is synthesis reaction. 2, decomposition reactions. 3, single replacement reaction. 4, double replacement reaction. 5, combustion reaction. So for synthesis reaction, it's also called a combination or an addition reaction. And these occur when elements are combined to form a compound. Take note of that. Elements are combined to form a compound. So that means you're going to have reactant plus another reactant to give you one product, just one product. So A reacting with B to give you AB. That's just one product. Examples, we have hydrogen reacting with oxygen to give you water, just one product. We also have carbon reacting with oxygen to give you CO2, just one product. So the next one is decomposition reaction. So it occurs when a compound breaks up into the elements or simpler compounds. Take note, when a compound, so that means you're going to have one reactant breaking down into products. So you have A, B going to A plus B. A, B going to A plus B. Okay, so for example, let's see. This is water breaking down into hydrogen and oxygen. Again, see, HgO, that's mercury oxide, is breaking down into mercury and oxygen. Okay, so sometimes before this decomposition reaction can proceed, it might require that you apply heat to them. So another types of reaction is single replacement reactions. So single replacement reactions occur when one element replaces another in a compound. Take note, one element. That means that you're going to react an element with a compound to give you element and a compound. So you are reacting an element with a compound. For example, let's see. A, of course, A is going to be an element. Then we have BC. The BC is going to be the compound. And what do we have? We have A is replacing B. So it becomes AC plus B. In other words, you can say A is displacing B. So A displaces B and then it becomes AC. Now, this will occur if A is a metal. Do you know why? Because you have to write the metal first. So AC means this is the metal and this is the A means that A is the metal and C is the non-metal. You don't write a non-metal first. You write a metal first, then you write a non-metal. Another example is, you can see A is reacting with BC. Now you see the product is BA plus C. That means A is a non-metal. That's why we're writing A as a second, and B will be the metal. So A is displacing C. So A is a non-metal here because we are writing it as a second one. Look at this. So a metal can replace a metal, or a non-metal can replace a non-metal. So when you are replacing them, always make sure that you write the cations first. So let's go to example to make it clearer. This is zinc reacting with HCl. So to produce zinc chloride and H2. So that means you can see that we are not writing Cl first before zinc. So we write zinc first because zinc is the cation. Then we write the chloride ion second, so to produce zinc chloride. If you see the example, you can see NaCl reacting with F2 to produce NaF and Cl2. So for this case, fluorine is displacing the chloride ion. So that's non-metal displacing another non-metal. The first one is metal displacing hydrogen. The second one is a non-metal displacing another non-metal. So in that case, you're going to have NaF plus Cl2. So when you have this kind of reaction, always make sure that they are balanced. Another one is double replacement reaction. So for double replacement reaction, it occurs when a metal replaces a metal in a compound and a non-metal replaces a non-metal in a compound. So in other words, you're going to have a compound plus another compound, giving you a compound and another compound. Okay, so for example, you're going to have AB, that's a compound, plus CD, okay, to give you AD plus CB. Now, take note, look at how we write the product, AD, okay, then we write CB. The reason is the first and the last ions go together. So the first is A and the last is D. So they form AD. Then the A side ions go together. That's the B is going to go with C. But in this case, C is cation. That's why we're writing C first. So it's going to give you CB because C is cation. It's not going to give you BC. It's going to give you CB because C is cation. Now let's use an example to make it clearer. You can see silver nitrate reacting with sodium chloride. So the first and the last ions, they will combine together. That means silver will go for chlorine to give you silver chloride. And then the inside will combine together. That's the nitrate, NO3, and the sodium will combine together. But remember, when they are combining, you're going to write the cation first. So it's going to give you NaNO3, sodium nitrate. The second example, K2SO4 reacting with barium nitrate to give you potassium nitrate and barium sulfate. So you can see that for potassium sulfate, the K is joining with the nitrate. The first and the last ions are combining, they're combining to form potassium nitrate. And then the sulfate, the inside ion, they're combining, that's Ba combining with the sulfate to give you barium sulfate. So it's not gonna be sulfate barium, it's gonna be barium sulfate. Okay, so the last reaction is combustion reaction. And what do we mean by combustion reaction? This is when this occurs when hydrocarbon reacts with oxygen. So you can also call it burning. So in order to burn, sometimes you need three things in the fire triangle. This is the fire triangle. And what do you need? You need a fuel, the hydrocarbon itself. You need oxygen. And then sometimes you need something to ignite, something that can cause the spark and then start to burn. So in general, This is the general equation that we have for combustion. CH is your hydrocarbon. Hydrocarbon means that the compounds that contain just hydrogen and carbon. So your carbon and your hydrogen together, the hydrocarbon, they react with oxygen to produce CO2 and water. And take note, when you have like a complete combustion, you always have CO2 and water. But when you have an incomplete burning or incomplete combustion, that's when you have CO2. So combustion is used to heat homes and run automobiles. So example is the octane, as in a gasoline. That's a C8H18. So let's do some learning check. So we should predict the right and balance the following synthesis reaction equation. Of course, you can see that if you remember what we discussed under synthesis, we have element A combining with element B to give you AB. So what is this going to give you? And then try to balance the equation. Again, what is this going to give you? And also equation. Then also identify the type of reaction for each of the following and write the balanced equation. So what reaction is this? What reaction is this? So identify the type of reaction. When you see the reactants themselves, then you should be able to say, okay, this belongs to single replacement reaction or double replacement reaction, or this is a decomposition reaction. So then you should be able to predict the product if you know the types of reaction. Then after that, you go ahead and balance the equation. So for library work, find more examples of combustion reaction. As you can see that we didn't really go deep into combustion reaction. So try to read more and find examples of combustion reaction. And this will be the end of lecture 4. So see you for lecture 5.